designs and how you create things for these machines, there's two real sides to it. You need the content, the objects, the ideas, and then you actually need the machine to be able to make it. So this evening I'm going to kind of talk about a few different areas of 3D printing. We're going to talk about CAD software, so computer-aided design software, which is what you need to use to create an object for this machine. We're going to touch a bit on scanning, which is another way you can create things 3D printed with these machines. I'm obviously going to give a demonstration of how it works. And I'm also going to talk a little bit about how you, as an individual, might want to explore your ideas or fabricate your ideas using 3D printing, and how you might take the initial steps to do that, and how you might find support and help to do that. So a good way to explain this process is to kind of use a case study. For the sake of example, I'm going to say, how do I take a character and make a 3D print of it? So what you're going to want to start off with is your concept and your initial idea. So in this case, we've got there's an artist called Stuart Holgate, and he does kind of characters and that kind of thing. He's worked for sort of Disney and different animators, but he, in this example, he's created this character, the sea thing, and he's got a lot of different concept artworks. Did I do all that? So yeah, so he has concept art and he has lots of pictures, and from that concept art he then creates his 3D models. Concept art or drawing out your idea is a really good place to start. Before you even sit down at the computer, you need to get your idea, maybe you write it down, maybe you draw it out. But the more you have and focus what it is you want to create with these machines before you actually sit down and learn software or get someone to make it for you, like with anything, the clearer it is in your head, the more likely it is what you get out of the machine is what you want it to be. Fortunately, this projector's interfering with my flow a little bit. Okay, so we have a concept. These machines understand digital files, so you're going to have to get what's in your brain into some sort of digital format that this printer will understand. To do so, you're going to have to use. Sorry, it might be much easier to explain if the slides are up, because bear with me for a minute. Stuart Holgate, conceptual art, sea thing, that's where we've got to. Okay, so you've got your idea, you're then going to take it into a digital space, and you do that using CAD. CAD stands for computer-aided design. In this case, we're going to be using a software called ZBrush. In layman's terms, there's two main ways you can divide CAD software for 3D files. Solid modelling, surface modelling, and organic sculpting. I will explain in a bit more detail the differences between those two softwares and how you might decide which one you want to learn a little later on. But for the sake of this example, you'll be using ZBrush. ZBrush is an organic sculpting sort of style of making shapes. You start off with a piece of digital clay and you can mould it and treat it almost like real clay. It has a very big tool palette, it's very intuitive. You can very nicely use it with a graphics tablet pen, so you can do sort of digital drawing with it. It's my preferred software of choice, but it's not good for product design necessarily, but it is good for characters. It's used a lot in the video effects industry, for sort of film and that kind of thing. But for taking a kind of character, something that's all flowy and wobbly, that's the sort of software you will be using. ZBrush is a paid-for software, but there's also a sort of little sister version called Sculptress, which is free. It's worth trying out before you decide what software you want to go to kind of try out the free ones. And there's a lot of free softwares. And as 3D printing becomes more popular, there's a lot more companies putting software or beta software out there for free so that people will engage with it. But yeah, ZBrush is fantastic, and Sculptress is a free little sister. So you've got your design and and you've made it into your 3D thing, you're happy with it, you've got it perfect from every angle, it's going to have to, you're then going to have to get it into the printer, and you need to turn that file into a language that the printer will understand. And you use different software for getting your design into that printer, and that software is called a slicing software. And that's the software which comes with the printers. Each sort of manufacturer or brand of printer will have its own slicing software, but fundamentally they all do the same thing. They take your 3D model and they slice it, because these printers work by depositing layers. Again, I'll explain how the printers work in a bit more detail in the demonstration, but the slicing software takes your nice cut that you're going to print, and it says, okay, the printer needs to know how to make this, it's building in layers. You're going to slice it into those layers, into that language that the printer understands. The variables with 3D printing, I'm talking about FDM machines, which is fused deposition modeling. It's these kind of desktop, accessible, cheapish machines. There's a variety of 3D printers, but these are a good one to focus on in a kind of group like this because they're accessible. Schools are buying them, universities are buying them, spaces like this, hack spaces or kind of community tech development spaces are buying these machines to let people use them. So that's sort of one of these machines tonight. Yeah, so the slicing software is going to create the file into a language that the printer will understand. Yeah, the variables. So I'll compare now a 3D printer to a 2D paper printer, which is something that normally you won't want to do. But with a JPEG, you have different resolutions, and that's to do with pixels. The more pixels you have, the higher the resolution of your image. With a 3D printer, the more detail you want to capture, the more layers you're going to have. That's the kind of comparison. So for higher resolution, more layers. The slicing software, slicing objects into many more layers. And the way you get more layers is by having thinner layers. So on a printer like this, you can go from 0.1 of a millimeter up to 0.3 of a millimeter in thickness. So at 0.1 of a mil, each layer is going to be 0.1 in height. And so for a 10 centimeter high figure, you're going to have 1,000 layers, basically. The more layers, the more detail. The other variable is infill. Infill is the strength of your piece at the end of the day. The infill is the amount of material, the density that your object is going to be built out of. The higher the infill, the more plastic, the stronger the piece, also the longer the print time. Again, when I show you the machine demonstration, I will explain that in a bit more clarity so it's clearer what's going on there. On the screen here, what you're looking at is the slicing software. So you have the path, the layer. This blue here is support materials. So designs that have overhangs are going to need support material when they're being printed to kind of maintain the structure. Once it comes out of the machine, you break that support material off. The slicing software lets you preview that. For me, I often use the slicing software to then go back to my design and improve it so there's less support material. One of my goals as a designer is to use as little waste material as possible. So slicing software for me, I like to just refer to it to check if there's going to be any sort of excess material that could be avoided if I just changed the models pose level. On this side, you have a kind of bird's eye view of the printer printing. Not this machine, but this one will be up. What you have here is an extruder head, and what we have here is what's been printed so far. That is that design. I've made that as well. But again, I'll go into more detail about what's going on that sort of shot there when we look at the machine. So that's receiving 3D printed. As you can see, it's pretty, what was in the ZBrush software is what we've ended up with there. Normally when you take things out of the printer, unless you're taking the time to make sure it's support-free, there is going to be some material that has to be cleaned up. There is going to be some post-processing. These machines aren't like the industrial machines where you just lift something out and it's finished. They do require often a little bit of cleaning, a little bit of fixing up, maybe a bit of painting. That's part of the pleasure of using them, in fact. So you can see here that this 3D print has been painted to create a finished piece. This is a very sort of basic example. It shows you how you go from idea to realization in 3D to printing and to a finished piece. The great thing about 3D printing is that you could have that drawing and you could have that finished print, that 3D object, within a couple of days, or even within one day if you're a quick worker. The amount of time from sort of conception to finished thing or 3D thing can be very, very short. And that prototyping period, which being so foreshortened, means that you can develop very, very fast. You can reiterate this design many times, which makes it quite an interesting tool for a variety of people, artists or engineers, product designers, So, how does it work? To go back a step. Basically, with the machine, what you have is a spool of filament. And this is a material that you print with. This normally comes in anything from 500 to a kilogram of spools, and it attaches most likely to the back of the machine. This filament is then fed up through a tube and pushed down into a heated extruder. So the filament's coming into a heated extruder with a material like PLA, which is one of the common plastics you use. This nozzle is heating up to 270 degrees to melt the plastic. And then you have your molten plastic coming out the other end in the path mapped by the slicing software. So your platform, your object, again, I can demonstrate the machine kind of that in action. But yes, basically, thread plastic going in, heated up, following the slicing software path, being deposited into layers to create a 3D structure. So, you want to create something. How many of you use CAD software or 3D software? Okay. Well, out of interest, what's 3D software? Yeah. Okay. And you?
Ages ago for landscape design.
Okay.
It was really good.
Okay.
Rhinoceros.
Pardon?
Rhinoceros.
Rhino?
Rhino, yeah.
And you?
And Modo.
What?
Modo.
Modo. Okay, so the variety there, we've got sculptor, we've got surface modeler, and possibly more solid modeling. It's a difficult choice to make what software you want to use, but I can give a kind of insight into the differences. Solid surface or surface modeling generally is used by product designers, architects, engineers. I can show you kind of what the workflow is like in this short video. This is an example of SolidWorks. I do also use this software. So you're working with planes, you're working with extrusions and solid shapes, solid masses. It's fantastic for moving parts, it's fantastic for tolerances, product design. It's got quite a kind of straightforward workflow. So you have to have a strong idea in your mind of what you want to make when it comes to this sort of software.
Looks like a piece of rubber.
It can do, yes. Don't worry, he's busy in 2 minutes. Okay. Okay, so that's solid modelling. You can kind of see how that works. Comparatively, ZBrush. So this is 45 minutes sped up into 2 minutes. Very different way of working. Basically, it's digital thread. We're using different brushes, different tools. The toolbox in ZBrush is very, very big. Clay build-up. I wouldn't stop reading off names, but they're very more like Photoshop. Maybe comparable to Photoshop. It's a very complicated software, but it's incredibly intuitive, and it's if you want to be making sort of sculptural pieces or characters or that kind of thing, ZBrush is probably the software of choice for that. ZBrush, Mudbox, free versions or similar versions like Free Sculptress and Blender. For surface and solid modelling, Rhino, SolidWorks. Rhino is actually available for free on Mac. It's a paid-for software on PC. SolidWorks is a paid-for software. Free versions, SketchUp and Tinkercad. Tinkercad is actually hosted online, so you don't even need to download anything. You can just enter it on the browser. The two quite different styles of modelling. They can actually work hand in hand. Sometimes I make my base model in SolidWorks and import it into ZBrush to apply detail. It doesn't work so well the other way around. We're saying you use Maya, you can make your base model in so Maya, 3D Studio Max. If you're interested in learning a software, do a bit of research. I'm giving just quite sort of just a couple of examples. There are many, but these are kind of primary ones that we use. So are there people here that are interested in learning design software? It takes a bit of time to decide which one suits what you want to do. I started learning SolidWorks and ZBrush at the same time. Generally, I use ZBrush more, but that's what I'm doing, sculptures and characters. I still see the use of SolidWorks. It's great for mechanical parts and tolerancing, which ZBrush is really not so great for. However, there's actually a new version of ZBrush that came out about a week ago, which does incorporate some better features for solid modelling. So I think as time goes on, the softwares will start to have more crossovers and they'll develop to kind of, not so become more and more similar, but share the useful functions of each other within their own softwares. So materials, what can we use with these machines? The two main materials we've been using is PLA, which is rigid, brittle, with a shiny finish, minimal warping, and is biodegradable. It's made from cornstarch. When you use it, there's sometimes a kind of sweet, sugary smell. That's when you know it's PLA. It has a lower melting point. ABS, it's rigid, resistant, and tough. It has a matte finish. It's good for kind of engineering parts, kind of prototyping parts. It's a lot stronger, but it isn't biodegradable. Biodegradable, anyway, is a bit of a funny term, even for PLA. And I think it's important with 3D printing to not be wasteful material. So if you are going to create something, it should be something that you tend to throw away anyway. So I don't know, but nylon is strong. We have flexible and rubber filaments, kind of a bit experimental. The sort of Ninja Flex, Fila Flex, there's a few different brands, but they're pretty cool. they are relatively new material. PET is food safe. You can't put it in the dishwasher, because it will melt. But it's also one of the clearer filaments. You'll never get like crystal clear glass looking filament for these machines, but this is pretty translucent. Then you have kind of specialist or mixed material filaments, things like wood fill, lay brick, bronze and copper fill. So these filaments, they still come in a spool like this, but there'll be a combination of materials. So there'll be PLA mixed with sort of sawdust to make wood fill, or lay brick, so it'll be PLA mixed with sort of powdered brick, the same with bronze and copper fill. There's a lot more of these materials coming into the market now, and it will just continue to increase. There's some pretty wacky ones. There's kind of carbon fiber filament, glow in the dark, various color changing filaments. That selection of materials is only going to get vaster. I think now there's sort of coconut filament, but it will develop in many different ways, not just what they decide to mix it with. As the machines develop, so will the materials, which is pretty exciting. And the great thing is, the files that we create today for these machines, these files can still be used in the further editions of the machines. So even though I might make a really high detail model and it doesn't come out in quite so much detail on a machine currently, in 6 months' time maybe the machine's resolution will be a lot higher and my model will come out. So I see a lot of, the machines are only going to get better, the materials are only get more diverse. So we're kind of really at the sort of first steps of consumer 3D printing, definitely this kind of last couple of years.
Do you need special machines for the specialist ones, or do they work with existing machines?
It depends. I mean, like the MakerBot you can use flexible filaments with. Wood fill, it depends on the brand of the wood fill. For example, I would often use the up machine, and the wood fill so works with that. With other machines, it's better. If you're going to buy a machine, it's best to seek the kind of information related to that specific machine. But you don't have to buy like a sort of specialist machine. But for example, does that make a machine you should be able to use a variety of filaments. You should be able to use PLA and ABS and probably specialist filament, especially new machines, especially more higher end machines. But it's also still a bit experimental. So which printers, that brings us nicely into printers. I'll explain quite briefly. Entry level pricing, you're looking at anything from like £500 plus for an assembled machine. You can get kit machines for a lot cheaper. That might be through like a kind of Kickstarter campaign, or I know like the PrinterBot retails for £500 as an assembled kit. But if you want to build it yourself, it's probably around £300. So yeah, sort of £500, but for a pretty good machine, £850 is a good entry level price. High end, yeah, you're looking more like £1,800, from £1,800 to £2,500. What's the difference? There's a few differences. Auto calibration, you're more likely to find on a high end machine. Things like the PrinterBot to level the print bed, which is important. The surface that you're going to be creating a model, you have to kind of twist it and do it manually. With something like a MakerBot or Automaker, the calibration should be automatic unless the machine gets really shook around. It should be able to calibrate itself. The slicing software in the higher end machines probably more developed and less buggy. But again, things like the FlashForge and the MakerBot actually share the same slicing software. It's a bit of a toss-up, really. I mean, I would say that the machines generally, you're going to get a bit more customer support, perhaps, with the more expensive machines. They have better manuals, but it's not always the case. Just trying to think what else. Yeah. It can also be to do with build size. The MakerBot has a big build space. I think it's 20 by 15 by 15 centimeters. Something like the PrinterBot has a much smaller build space, so you're not going to get big objects out of the printer. So what can you make? There's a variety of things. If you decide that you're not going to make things yourself, there's also places where you can find files. But commonly the sort of things that people make could be gadgets. What we have here is a printed buoyancy aid for a GoPro. You might want to do kind of gadgety kind of hack things. Props is another one. This was printed on a MakerBot in separate parts, and post-processing was used to decorate it. Product design, maybe we can use it for creating homewares, that kind of stuff. You can use a printer for the prototyping stage, or you can use it for the final thing. You're not going to necessarily get away with this prop in Star Wars or whatever, but maybe for like a kind of amateur film or something, this would be a fun way of getting some kind of cooler looking props. For hacks and gadgets, things with GoPro are often super expensive. If you want a 3D printer, you can print out your own kind of accessories. Something, this makes a lot of sense. For product design, again, maybe you get things out of a machine that you'd not necessarily consider a finished product, but in terms of trying out designs and reiterating designs, it's a really incredible way of having something in your hand, especially if you know how to use 3D software. Rather than having to wait weeks and weeks, for a model maker to do something, or having to really get to a pretty far along the line in your development to actually be able to invest money manufacturing something. For a design studio with this in your hands, you can test out your design very, very quickly. So those are a few of the things you might use it for. So I'm going to show you a couple of examples of instances where people are using this technology in their practice. This first example is a company called Board Concrete. They use a 3D printer to create molds, which they then pour concrete into to create these kind of homewares. I like this example just because it shows how you could use one of these printers to kind of have a start to finish business, probably in a very small space, probably from home if you wanted to, regardless of what this product is or isn't, or how good it is or isn't. You could use basic software to create the design very, very quickly, in comparison to sort of traditional mold making, which requires like silicone or wax or messy space. With the FDM printer, you could create the mold, print it without kind of creating any kind of mess. You could do it in quite a small space. Obviously, with the concrete, maybe a bit of mess, but probably not too much. They sell their products through Etsy. Again, you can do that from home. 3D printing can allow you to manufacture things in a small space, on a small budget, and I like that idea of grassroots small business. There's a lot of people using these machines for that.
What's the red thing?
Pardon?
What's that red thing?
That's, okay, so they have the outer mould, and that red thing would be the central cavity. Yeah, I think they're using it. I mean, it's a cute-ish product, whatever, but it's traditionally, how would you have made this? Traditionally, traditional isn't really the right word, but 10 years ago, what would you have used to make these, and how long would that take in comparison to how you could do it now? That's kind of more what I'm interested in this example. Another example, Pussy Crew. This is a duo of artists. I think they're originally from from Poland, but they're based in Berlin. They use Ultimaker 2 to create fine art sculptures. I think they use 3D Studio Max to create the designs. They use a lot of different post-processing techniques to get their finished pieces, but the core of the sculpture is done with their 3D printer in their studio. I've spoken with them. They said it normally takes them about 2 weeks to make a sculpture. The printing may only take a few days, but then they use, sort of a range of resins and different processes to then create a finished piece. 3D printing can be a nice step in your practice or in your sort of creative way of doing things. This is quite a good example of that. I don't know, with the finished piece, if you looked at it, you probably wouldn't expect it to come from a sort of £2,000 machine. Pretty nice. Again, it's a nice example of how post-processing can take what perhaps straight out of the machine doesn't look so impressive and take it like a step further. So that's another thing to think about. Like, I don't know what each of you as individuals sort of do, but probably your brain is ticking of like, well, where could I use this? How could this be useful for me? What can I do with these machines? Or where could they play a part in what I already do? There's always ways. You just need to have a think, I suppose. So outside of CAD software and then purchase software, another way of getting files for this machine is through scanning. The example I'm going to use to sort of explain that is an initiative from MyMiniFactory, which is a file sharing platform that I'm a designer for. We have an initiative called Scan the World. Scan the World currently is about just over 600 printable scans of sculptures, objects and artifacts from around the world. There's a few of them there. There's a few of them on display at the Manchester Science and Industry Museum. Scanning is quite an interesting one. And there's sort of two main ways in which you can approach scanning. So one way is with a handheld or tabletop laser scanner. They've been using scanning in sort of film and quite a few different industries for a long time. Even dentists use scanners to capture the 3D data of your mouth if you're going to get a special brace made, for example. In films, they might use it. I know at Pinewood Studios, they scan objects and then they use that data for the CNC machines. Basically, the laser goes out, touches the object, and in real time captures that as digital information. You can buy desktop scanners, they're about £700, or you can buy the sort of proper industrial ones, they're a little more expensive. There's a big difference in price, but I'd actually say ScanWorld doesn't use either of these devices. ScanWorld uses something called photogrammetry scanning, aka using RoboCam. Photogrammetry works by taking many pictures of your object. So I'm not going to go into a huge amount of detail about how it works, but to capture a sculpture, you probably want to take between 40 and 60 photos. And the thing about Scan the World is that one of its main sort of focuses is about community engagement. So Scan the World is made possible by a big load of photographers and a big load of ZBrushers who fix the files. Anyone can contribute to Scan the World and anyone can do a scan. As long as you have a camera, it could be a fancy one or it could be a camera phone, you can capture the data required to put together a scan. You don't have to have any CAD experience. It is possible. There's still some steps that have to be taken to get a good quality object to print, but fundamentally it is possible to capture that data and print it. There's really no experience of using these machines or using CAD software.
Say that scanner we have here.
Yes, you have a scanner here, which I've never used before.
It attaches to an iPad.
Yeah,
It's about
totally.
£300 and it uses infrared, I think.
Cool.
It's called structure sensor.
Yeah, I'm looking at the shoebox, which is
Yeah.
the actual
The
box.
box that came in is a bit on the story, but
Okay.
it was a Kickstarter. And there's two versions. One is a handheld, which you have to have a cable connected to a laptop, and this one's an iPad, which you can wirelessly send the image to free software on Mac, I think, on a laptop. I haven't used it that much, but it's pretty good.
Mm.
It's pretty good. Yeah, for the price. you can download the software off the structures and some websites, but they're different kinds.
But
But it does end up still, the all you do met and everything,
Yeah.
tidy up a lot.
yeah, I'll talk a little bit about sort of some version ones of that. Yeah, so photogrammetry is quite an accessible way of capturing the scan. Scan World, it said, has 600 printable files from scans. These come from all different sorts of places: sculpture parks, museums, and sort of galleries, basically. And so we have quite a few photographers that go around and do these scans and send them to us. Softwares. So 123D Catch is a phone app. I think it's on Android and Apple. There's also a desktop version and it's free. Project Memento is only for computers, but it's high quality. And the beta version is available and it's free. Paid software, I just thought PhotoScan is expensive, but it has a lot of features. It's the kind of high-end software that you'd use for processing scans. What you see on this side of the screen is image cloud. And what these softwares would be doing is taking our 40 to 60 photos of the sculpture and piecing them together. To build the subject. So that's what we're seeing on the screen here. The softwares work on different algorithms. So 123D Catch, phone app and desktop, has an algorithm of piecing together the images that's not as effective as Project Memento. That's why I say that Project Memento is high quality, because of the algorithms that the software are using to piece together the photos. Agisoft, where I say step by step, we have a lot more control over how software pieces together images, and we can go into a lot more sort of finicky adjustments to get a very nice scan out of it. It's kind of so original sculpture and 3D model pieced together as software. You do lose some detail, but again, this is advancing. This is pretty new technology in terms of consumable technology. Again, in big industry, if you can spend 18,000 on a scanner, you can get final results. But considering you can make all of these models with just your camera and free software, it's kind of happening. It's closing the difference in what technology is accessible to do. And that's a 3D print from the scan. That's where we're at currently with scanning. There's still a long way to go, but it's exciting. Scanning can also be done on a much higher level, like I just sort of said, but in terms of home use, this is the kind of thing we'll be looking at. And again, you know, there's free apps, there's free software, devices which connect to iPads, so it's becoming more accessible. Do you have a question?
I'm just wondering what sort of scanner companies like Staples are using, because they're doing scanning in 3D models of people, aren't they?
Yeah.
They're using the 18,500 scanner.
It depends. For example, at the iMakr store we have a scanning booth, and that's constructed from about 40 SLR cameras. So those cameras are each about £500. Still, 40 of those cameras is still a hell of a lot less than the sort of industry scanner, but the quality is good enough for doing kind of the photo prints of the figurine. Definitely high enough quality. Staples, I'm not sure. It depends. They're probably not. They probably don't have someone working there with their phone out and scan. Yeah, I'm
Well,
not
let's
sure.
explore that, because it's novelty value, but it's introducing it to a much wider audience.
Yeah.
For some obscure reason, people might like the sort of image of
Themselves on the mountain. Yeah. Well, yeah. I mean, we make those busts and figurines, and we do it using a sort of big frame with no mini cameras attached, and the quality would be nice. So with all this, with the machine you have to have the content. With this content, it needs to be somewhere, it needs to be accessible, it needs to be, it doesn't need to be, it can be. MyMiniFactory is the website I work for. We launched in June 2013. We have a huge library of files which is growing rapidly. We have three main sources of files. So we have an internal design team, which is about 12 people. We have user uploaders, so that's our design community who send us files to share. And then we have the designers exchange, where people can get paid work through fulfilling online briefs through the website. So that's kind of external freelancers. Those are the three main sources of files. Yeah, it's a growing platform. We're developing a lot of different tools for the website to make it enjoyable for designers, but also to engage with the 3D printing community to find out what it is that they want to have available to use with their machines. As a designer, why would you bother putting your designs online for free or whatever? There's a number of reasons. It could be to do with portfolio building. It could be to do with getting feedback. It could be to do with engaging with your audience. On the website, each object gets its own page and has photographs. You've got description. People can leave comments. People can submit their photos of them having printed it. The thing about MyMiniFactory that makes it different from other file sharing platforms is that the content is curated. We print test every design. Theoretically, nothing on the website won't print. Other websites, Thingiverse as an example, has some fantastic designs, but it also is a bit swampy. There's many things that don't print, things that would never print. So the idea of MyMiniFactory is that we curate the content, so we have a sort of validation process. We also engage heavily with the design community, that's important to us. We have quite a lot of different opportunities available through the website. Regular design contests. On the left-hand side, this was a competition along with Portuguese event called, Unicorns, Trojan Horse, I think. Trojan Horse was Unicorn. It's a sort of video effects event that happens for a few days in Portugal. We ran a competition where their community could design a Wacom pen holder, and the most popular design would win a ticket to the event. We have many different competitions on a regular basis. We currently have one to design parts for GoPro. We have another one for designing jewellery for Valentine's Day. The first prize is a resin printer, which is worth about $5,000. So we have regular competitions. We then have more sort of design sourcing, crowdsourcing projects. One with Oxfam, where we had the Oxfam team had a printer on location in Lebanon, and they set the challenge of how can we improve hand sanitisation devices in this sort of situation. The product development it takes, and the amount of resources it takes to bring new resources to these sort of on-site places is very, very difficult. So the idea with this is that by having a 3D printer, they could test out new designs very quickly on location, feedback, and kind of test things out on the field. So we had a kind of, it's actually I think it's still ongoing, open submission where designers could submit their solution to the hand sanitation device, and then we'd go through them to make sure that they were feasible and printable. And then printable designs were then sent to the team in Lebanon who printed them and tested them out, and go back to the designer to reiterate the designs. It's not a competition, it's a community open source development project. Yeah, so that's another example of the sort of thing that happens on MyMiniFactory. Kind of coming to the end of my presentation, my main thing is if you have an idea, go for it. you're sat here for a reason, you come to this event for a reason, hopefully because you're interested in technology. That means there's something in your brain telling you, oh, this is interesting, maybe I can use this. Go for it, the tools are there, 100%. Firstly, your idea. What is your idea? Draw it out, write it down, think about it, see what's been done before, see what you could do differently. Your idea, like, don't let it fly away. Get it down, it's so important, and it's the first step, and it's the biggest step, and it's a thing that many people don't do, and I wish they did. So your idea, explore it. Before you even look at how a machine works, explore your ideas. Technology, you can use technology to prototype things very, very quickly now. That's one of the beautiful things about these machines. And just generally, technology helps with prototyping ideas. I want to make a short film, I'll do a teaser, I'll put it on YouTube. Oh, do my friends like it? Yes, they do. Maybe I'll put a bit more time into it. Technology is helping us to prototype ideas and explore things and share them a lot more rapidly. That's to do with community and feedback. Again, the internet can be used to test things out and decide if they're a good or bad idea. It can happen very quickly. You can get an opinion from 50 people with one tweet. Not necessarily the way you want to go about doing things, but this is a kind of society world we're in at the moment where things can happen very quickly. So if you have an idea, go for it. Why not? It's worth it. The tools are there. In the same way that WordPress makes creating a website pretty easy, 3D printing makes prototyping a product idea or a character idea or whatever pretty easy, or a lot easier than it was 20 years ago. Once you have your thing that you're happy with, that you're excited about, websites like Kickstarter make it a lot easier to find funding for those ideas. It's becoming easier. We're living in a time where things can happen fast. It doesn't necessarily mean that we shouldn't still think carefully about what we want to do, but it means that you should never feel like you can't do anything. These machines are as much use, and they are being bought by not only design studios, but by students, and not university students, but secondary school students, to play around with. What this machine can achieve in the bedroom of a 15-year-old could actually have a big impact on how they do things over a period of time. The way that this machine can be used by a product designer to try things out could very rapidly increase the rate at which they get their idea from a spark in their brain to in the hands of someone in a shop. So again, it's the same, like, why not go for it? I'm from iMakr. I work for MyMiniFactory. I'm a 3D designer. I've found 3D printing has been really useful for me. I started out as a community manager, and I have now returned back to doing design work. The company can do things in many different ways. We have a print on demand service, a kind of accessible design community. Even if you have an idea but you don't have the CAD design skills, you can use MyMiniFactory or whatever website to find yourself a freelance designer who can make those things happen.